Hello and welcome to this edition of News Today. Without delay, let's have a look at the headlines first. Cambridge scientists discovered biosignatures on exoplanet K2-18b using James Webb Space Telescope. Bose Institute scientists receive Breakthrough Prize in Fundamental Physics. C-Dot and Sterlite Technologies Limited tested India's first quantum key distribution over multi-core fiber. India and International Big Cat Alliance signed headquarters agreement. Devasthal Optical Telescope detected and measured the properties of an IMB edge. IIT Bombay scientists developed lotus leaf-like solar evaporators for salt water treatment. In a groundbreaking astronomical breakthrough, Cambridge scientists have discovered potential biosignatures on the exoplanet K2-18b using the James Webb Space Telescope or JWST. This discovery marks a significant step forward in the search for extraterrestrial life. The highlight of the findings is the detection of two chemical gases, dimethyl sulfide or DMS and dimethyl disulfide or DMDS. On Earth, these gases are primarily produced by marine phytoplankton, algae, indicating potential biological activity. Interestingly, earlier, James Webb Space Telescope observations had already revealed the presence of methane and carbon dioxide in K2-18b's atmosphere. Let's dive into the details now. The scientists observed that the concentrations of DMS and DMDS on K2-18b are thousands of times stronger than what we find on Earth. These results were achieved using the transit method, wherein, as K2-18b transits, James Webb Space Telescope detected a drop in stellar brightness. This has led scientists to classify K2-18b as a high-SIN exoplanet, a habitable ocean-covered planet underneath a hydrogen-rich atmosphere. In terms of scientific accuracy, the findings are notable. The observations have reached a 3 sigma level of statistical significance, which means there is only a 0.3% probability that the detection is due to random chance. So, what do we know about K2-18b? It is an exoplanet, meaning a planet beyond our solar system, and is 8.6 times more massive than Earth, with a diameter roughly 2.6 times that of Earth. It orbits a cool dwarf star named K2-18, situated in the star's habitable zone, about 120 light-years away from us in the constellation Leo. This discovery wouldn't have been possible without the powerful capabilities of the James Webb Space Telescope, launched in 2021. James Webb Space Telescope is a result of international collaboration between NASA, the European Space Agency, and the Canadian Space Agency. Designed to explore the early universe, star formation, and planetary systems, it orbits the Sun 1.5 million kilometers away from Earth, at what is known as the second Lagrange point or L2. With biosignature gases now detected on a distant world, the quest for life beyond Earth has taken an exciting leap forward. In a moment of immense pride for India, the Experimental High-Energy Physics Group of the Bose Institute has been honored with the Breakthrough Prize 2025 in Fundamental Physics. This prestigious recognition comes as part of their contribution to the ALICE experiment at CERN. Let's take a closer look. Now, the Breakthrough Prize 2025 has been awarded to researchers from over 70 countries, representing 4 experimental collaborations at CERNs. Large Hadron Collider or LHC, namely ATLAS, CMS, ALICE and LHCb. These prizes were conferred for several groundbreaking achievements, detailed measurements of Higgs boson properties which confirmed the symmetry-breaking mechanism of mass generation, the discovery of new strongly interacting particles, the study of rare processes and matter-antimatter asymmetry, and for exploring the nature of matter at the shortest distances and most extreme conditions at the LHC. Now let's take a closer look at these 4 powerful collaborations at CERN. First, we have ATLAS, or a toroidal LHC apparatus, which stands as the largest detector ever built for a particle collider. Then there's CMS, or the compact muon solenoid, a general-purpose detector used not only for studying the standard model, including the Higgs boson, but also for searching for extra dimensions and particles that could make up dark matter. Next, we come to ALICE, or a large ion collider experiment, which is at the heart of India's achievement. ALICE specializes in studying quark-gluon plasma, an exotic and extremely hot and dense state of matter that existed in the first microseconds after the Big Bang. Finally, LHCb, or Large Hadron Collider Beauty, is dedicated to exploring the subtle differences between matter and antimatter by analyzing particles like the Beauty quark, also known as the B quark, which is the second heaviest known quark and carries a negative one-third electric charge of the elementary charge of electron. All of these experiments take place at CERN, the European Organization for Nuclear Research, which was established in 1954 as Europe's first joint venture after World War II. Located on the Franco-Swiss border near Geneva, Switzerland, CERN is an international scientific organization devoted to collaborative research in high-energy particle physics. It consists of 23 member states and 10 associate member states, with India proudly being one of the associate members. This remarkable recognition of Bose Institute scientists not only celebrates their contribution to global science but also reinforces India's growing presence in the international scientific community. In a major leap towards secure communication technology, CDOT, in collaboration with Sterlite Technologies Limited, has successfully tested India's first quantum key distribution over multi-core fiber, or MCF. Now, what exactly does this mean? Well, multi-core fiber technology allows data to be transmitted across multiple cores within a single fiber, which significantly help in saving physical space and reducing infrastructure cost. But the real game changer here is quantum key distribution, commonly known as QKD. This is a secure communication method for exchanging encryption keys that are known only to the shared parties involved. It utilizes the unique properties of quantum mechanical systems to generate and distribute cryptographic keying material using special purpose technology. So, how does it work? QKD involves the transmission of photons, tiny particles of light, over fiber optic cables. Each photon carries a random quantum state, and together they form a stream of ones and zeros known as qubits. There are mainly two types of QKD protocols. First, we have the entanglement-based protocols, where a source generates entangled pairs of quantum states, and each party receives one part of the pair. Second, the prepare and measure protocols, where the sender prepares a quantum state, often as a superposition of polarization states, and sends it to the receiver, who then measures it. The key advantage of QKD lies in its ability to detect and mitigating eavesdropping, the act of listening to, recording, or intercepting private communications attacks. However, it's not without its challenges. QKD brings with it higher infrastructure cost, the risk of denial of service attacks, the need for specialized equipment, and integration difficulties with existing networks. Despite these limitations, this recent test marks a critical step forward in India's pursuit of next-generation secure communication, merging cutting-edge quantum technology with innovative fiber optics. In a significant step toward global wildlife conservation, India has officially signed the Headquarters Agreement with the International Big Cat Alliance, or IBCA. This agreement cements India's role as the host of the IBCA headquarters and its secretariat, enabling the organization to efficiently carry out its official functions. The agreement covers a range of provisions, including visa facilitation, as well as privileges and immunities for the IBCA secretariat, its personnel, and premises. Additionally, India has committed budgetary support of 150 crore rupees. This support is aimed at creating a corpus, developing infrastructure, and meeting recurring expenses for a 5-year period, starting from 2023-24 and continuing through to 2028-29. To understand its background, the IBCA was launched by India in 2023 as part of the commemoration of 50 years of Project Tiger. It marks a major milestone in global conservation efforts, starting January 2025 with the enforcement of its framework agreement. The IBCA and its secretariat will become a full-fledged, treaty-based intergovernmental international organization and legal entity. So far, 5 countries, Nicaragua, Eswatini, India, Somalia, and Liberia, have formally signed the framework agreement, becoming members of the alliance. The core aim of IBCA is the conservation of 7 big cats: the tiger, lion, leopard, snow leopard, cheetah, jaguar, and puma. Out of these 5 species, tiger, lion, leopard, snow leopard, and cheetah are found in India. India's leadership in big cat conservation also aligns with earlier global efforts, including the St. Petersburg Declaration on Tiger Conservation, signed in 2010. This declaration brought together 13 tiger range countries with the shared objective of TX2 goal, or doubling the global tiger population by 2022. With the IBCA now gaining momentum, India continues to lead from the front in global biodiversity protection and big cat conservation. In a significant leap for space research in India, the Devasthal Optical Telescope, or DOT, has successfully detected and measured the properties of an intermediate mass black hole, commonly known as an IMBH. This groundbreaking discovery comes from the scientists at the Aryabhatta Research Institute of Observational Sciences, or ARIES, an autonomous institute under the Department of Science and Technology. Commissioned in 2016 and located in Nainital, this 3.6-meter optical telescope holds the title of being India's largest telescope for studying celestial objects at optical wavelengths. It is maintained and operated by ARIES and has now added another feather to its cap. Coming to the discovery. This particular IMBH lies in a faint galaxy approximately 4.3 million light-years away. What makes the finding so fascinating is the observation of a gas cloud orbiting the black hole at a distance of about 2.25 billion kilometers, with a velocity dispersion of 545 kilometers per second. This is especially noteworthy because intermediate mass black holes have largely remained elusive. Their faint nature and tendency to reside in small galaxies mean they usually don't emit bright signals, unlike their more massive counterparts. Now, what exactly is a black hole? In simple terms, it's a region in space where an enormous amount of mass is packed into an incredibly tiny volume, producing a gravitational pull so powerful that not even light can escape. Due to this, black holes are invisible to traditional telescopes. They neither emit or reflect light. They are typically formed when giant stars collapse, and they are surrounded by a boundary known as the event horizon. So, how do we detect them? Scientists rely on indirect observations based on their impact on surroundings through, like accretion disks, which are rings of gas and dust surrounding black holes, or gravitational waves, the ripples in space-time created when massive objects accelerate through the cosmos. Studying black holes is not just about spotting a distant object. It's about unlocking the fundamental secrets of the universe, allowing us to test core scientific theories such as Einstein's general theory of relativity and aspects of quantum physics. Black holes are categorized into three main types based on their mass. Stellar mass black holes have masses ranging from a few to a few hundred times that of the Sun. These black holes increase in mass primarily through collisions with stars and other black holes. Intermediate mass black holes, or IMBHs, are considered as missing link in black hole classification. They typically have masses ranging from around 100 to hundreds of thousands of times the mass of the Sun. Scientists are actively searching for these elusive objects due to their unique position between stellar and supermassive black holes. Supermassive black holes, on the other hand, have masses ranging from hundreds of thousands to billions of times that of the Sun. These gigantic entities grow by feeding on smaller objects like stellar mass black holes or neutron stars, and may also merge with other supermassive black holes during galactic collisions. With this recent breakthrough by Indian scientists using indigenous technology, we move one step closer to understanding the mysterious and magnificent universe around us. Scientists at IIT Bombay have made a groundbreaking advancement in the field of water purification by developing lotus leaf-inspired solar evaporators for saltwater treatment. This innovative system uses a hydrophobic graphene-based material that mimics the natural water-repellent surface of lotus leaves. By enhancing solar desalination processes, this breakthrough could offer a sustainable solution to the intensifying freshwater crisis around the world. While it is true that water covers approximately 71% of Earth's surface, only 3% of this is fresh water, and out of that, only 0.06% is easily accessible for human use. The remaining fresh water is either locked in glaciers and polar ice caps or lies deep underground and in swamps, making it difficult to access. Consequently, desalination has emerged as a key technological intervention to bridge this critical gap in water availability. Let's take a closer look. Desalination technologies are generally divided into thermal and membrane-based processes. Thermal technologies involve heating saline water and collecting the condensed vapor to obtain purified water. Its usage is seen mainly for seawater desalination. This category includes methods like multi-stage flash distillation, multi-effect distillation, and vapor compression distillation. Merits include the availability to reduce the maximum salinity concentration and also demands less input electrical energy compared to the membrane techniques. But they rely heavily on conventional energy sources like coal, making them expensive and environmentally taxing. So, it has rarely been used for brackish water desalination. For instance, low-temperature thermal desalination plants have been set up in the Lakshadweep Islands including Kavarati, Minicoy and Agatti to address local water needs. On the other hand, membrane-based desalination operates by pushing feed water through semi-permeable membranes which filter out dissolved solids. Its usage is mainly seen for brackish water desalination. The key processes under this category are reverse osmosis and electrodialysis, or its variant, electrodialysis reversal. These technologies are considered more eco-friendly, particularly ED, which eliminates the need for chemicals and typically occupy less physical space compared to thermal systems, thus leaving a smaller footprint. However, they come with their own set of challenges, such as susceptibility to membrane fouling, high maintenance demands, and issues related to membrane waste disposal. This method may also not fully remove total dissolved solids or TDS or pathogens. Despite these drawbacks, such technologies have been successfully deployed as facilities like the Nimili seawater desalination plant in Tamil Nadu on reverse osmosis, which stands as South Asia's largest RO-based desalination plant. In summary, this innovation could be a game changer in providing decentralized desalination solutions, particularly in remote and resource-constrained areas. In today's Personality News, we turn our focus to Dr. Sarvepalli Radhakrishnan, an eminent statesman and India's second president, was remembered on his death anniversary, April 17th. Born in a small town in Andhra Pradesh, he was a renowned Indian philosopher and a firm believer in education as a transformative tool for society, and his birthday, September 5th, is celebrated as Teachers' Day in India. Now, let's look at his key contributions. He served as Professor of Eastern Religions and Ethics at the University of Oxford and India's ambassador to the Soviet Union from 1949 to 1952. He also served as the Vice President from 1952 to 1962 and President from 1962 to 1967 of India. His notable works include the Principal Upanishads, the Hindu View of Life, and Dhammapad. He was awarded knighthood in 1931 and the Bharat Ratna in 1954. As we conclude today's main news, let's have a look at some quick updates. Kerala becomes first state in India to launch online Permanent Lok Adalat services. Permanent Lok Adalat is organized under Section 22B of the Legal Services Authorities Act 1987. Same powers as are vested in a civil court under the Code of Civil Procedure 1908. Recently, National Organ and Tissue Transplant Organization has written to states, UTs, to implement swap organ transplant. Swap organ transplant is a process where two or more incompatible donor-recipient pairs swap their organs. From April 2025 onwards, All India Index of Industrial Production will be released on 28th of every month within 28 days from the current 42 days from the reference month. Further, only two estimates, Quick Estimate and Final Estimate, would be released instead of the earlier practice of releasing three estimates. Financial Intelligence Unit India or FIU-IND and Reserve Bank of India signed an MOU for coordinated efforts towards effective implementation of the Prevention of Money Laundering Act and rules framed thereunder. FIU-IND was established in 2004. A study commissioned by the Office of the Principal Scientific Advisor recommended the rollback of the 2015 policy mandating the installation of FGD systems in all of India's coal-fired plants. Rather, it recommended FGD to only those plants using imported coal or high sulfur coal. Research indicates sign of geological changes, elevation of the dried land of the basin since the water disappeared on Aral Sea. Aral Sea was once a large saltwater lake of Central Asia and it lies on the boundary between Kazakhstan north and Uzbekistan south. Kerala State Electricity Board and the Indian Institute of Technology Bombay have initiated a pilot project to explore the implementation of vehicle-to-grid technology. V2G refers to technologies that enable EV batteries to send power back to the grid. South Africa's Cradle of Humankind caves reopened for public after being closed for 3 years ago due to flooding. Cradle of Humankind is a UNESCO World Heritage Site dotted with subterranean limestone caves. It's located near Johannesburg, South Africa. Before we sign off, let's challenge your understanding in today's installment of Test Your Learning. Thank you for joining us. We hope you found this episode of News Today engaging. For the solutions to the quiz and to access the PDF version of News Today, remember to visit the provided links in the description below.